Welcome to Nicholls State University's online developmental course. In this lecture, we will be looking at an introduction to exponents and square roots. We will begin with an introduction to exponents. A product of two numbers, for instance, 3 times 3, may be written as the exponential expression 3 raised to the second power. The 3 is called the base, and the 2 is called the exponent. The power, or exponent, represents how many times the base is used as a factor. A number raised to an exponent represents repeated multiplication of the number. For example, 2 raised to the 5th power has a base 2, an exponent 5. The exponent 5 tells us that we will multiply the base 2 times itself 5 times. This equals 32. To better understand this concept, we will start with application problems. In our first application problem, we will find the area of a square. From geometry, we know that all 4 sides of a square are the same length. And in order to find the area of a square, we must multiply the length of the sides of the square times itself. For example, here we have a square in which each side of the square has length 7. To find the area of the larger square, we must multiply 7 times 7, which is the same as raising 7 to the second power. This equals 49 square units. That means there are 49 squares with sides length 1 that make up the larger square. For this reason, it is common to use the phrase 7 squared to express 7 raised to the second power. Of course, this is true for any base squared. In our second application problem, we will find the volume of a cube. Recall from geometry that a cube is a prism with 6 identical square faces. The faces are joined by edges, and each face has 4 edges, each with the same length. For our example, we will consider Rubik's cube, in which the side edges are all 3 units in length. To find the volume of Rubik's cube, we multiply 3 times 3 times 3, which is the same as 3 raised to the 3rd power, which equals 27 cubic units. That means there are 27 cubes with sides length 1 that make up Rubik's cube. For this reason, it is common to use the phrase 3 cubed to express the exponential expression 3 raised to the 3rd power. It is important to realize that the term cubed may be used when we raise any base to the 3rd power. Our next topic is square roots. We will start with an example. We can write the number 9 as 3 squared, and we call 3 a square root of 9. Additionally, -3 is a square root of 9, since -3 squared is equal to 9. We will now look at the definition. If x squared equals k, then x is a square root of k. All this says is if you have a number x and you square it and it equals to another number, then the x is a square root of that number k. It is important to remember that x squared will never be negative in the real number system. Because of this, a negative number will never have a square root in the real number system. The symbol given here is called a radical sign, and this is often used to represent what is known as the principal square root of a positive number. The principal square root is the non-negative square root of a number. In our first two sentences above, we said that 3 is a square root of 9, and negative 3 is also a square root of 9. But when we are looking for the principal square root using this symbol, we are only looking for the non-negative square root, which would be the 3 in that example. For another example, the square root of 25 is used to represent the non-negative square root of 25. Therefore, the value of the square root of 25 is 5, since 5 squared equals 5 times 5, which equals 25, and 5 is the positive square root of 25. We will now look at possible problems that you may see on an ACT or an ACT Compass test. For the first example, we are just asked to simplify the square root of 121. Since 11 squared equals 121, the square root of 121 equals 11. On a test, there could be variations of these types of problems. That's why it's important that you understand that since 11 squared equals 121, the square root of 121 equals 11. On a test, they may ask the question in different forms, possibly including true and false questions. But for our next example, it will be a fill-in-the-blank question. 22 squared equals blank, so the square root of blank equals 22. 22 squared equals 484. So the square root of 484 equals 22. Notice that the answers are exactly the same. We filled in the blanks with the same number. It is important for you to understand this in case they ask you the question as a fill-in-the-blank or a true-false question.